Hi, welcome back. In this video, we're continuing to look at graphing square root functions. In the last video, we looked at transformed functions and how we would graph them. And now we're going to look at a couple examples. So in my first example, we are going to look at these two square root functions. We've got y equals the square root of x minus 2 plus 5. You'll notice that when I write these, I tend to put a little line at the end of my square root. Make sure I know where it ends. I find that a lot of times when I don't do this, especially when I've got numbers and things, I will be imprecise with this and be unable to tell if this 2 is inside or outside. So that's just my little tip, is that little line at the end of your square root. All right, so graphing this. The first thing that we did when we started with our transformed function is we looked for the domain. So I could be identifying a, h, and k, and maybe I will right now. So my a value is positive 1. It's what's in front of my square root. My h value is positive 2 because it is x minus h. I have x minus 2, so it is positive 2. And my k value is positive 5. So this means my graph is shifted to the right 2, up 5. It's not stretched, it's not flipped vertically. Okay, so now I want to start by looking at my domain. My domain restriction comes from what is underneath here. So this is x minus 2 needs to be greater than or equal to 0. X needs to be greater than or equal to 2. So that is 2 to positive infinity. That means that I'm going to make a table down here, and I'm always going to have my vertex be the first point. So 2 is the x value of my vertex. So when I plug that in, I get the square root of 2 minus 2 plus 5. This is 0 plus 5, so this is 2, 5. So that means my vertex is at 2, 5. So 2, 1, 2, 3, 4, 5. I'm not only going to graph that, but I am going to label that with the ordered pair coordinates of what that point is. The vertex, as I mentioned before, is the most important point, so we need to make sure we mark it and indicate what it is. So now at this point, I am going to want to find the range, but I'm going to graph a few more points. Like I said before, we want to be kind to ourselves about the points we plug in. So I would like what's underneath here to be equal to 1. So if I want what's underneath here, so I want x minus 2 to be equal to 1, I'm going to plug in 3 for my x value. So if I plug in 3 for my x value, that's going to give me the square root of 1 plus 5. That just becomes 6. So I have the point 1, 2, 3, 6. All right. Now I want x minus 2 to be equal to 4. So that means I should plug in an x value of 6. So that gives me 6 minus 2 is the square root of 4 plus 5. That is 2 plus 5, or 7. So now I have 1, 2, 3, 4, 5, 6, 7 right there. So I have 3 points. I am going to graph like that. And remember, we're kind of starting vertical and flattening out through those points. So now I can look at my range, and my range appears to start at 5, and it's headed up. So that means it's going to positive infinity. My a value is positive, so that matches what I expected, right? If my a value is positive, it should be from k to positive infinity. Perfect. All right, moving on to the next one. In this case, I'm going to record a, h, and k down here. So a is negative 2, h is negative 3, and k is negative 1. So this is my a value. My h value is x minus negative 3, and my k value is negative 1. So I have those. This means that my graph is going to look like this. This means that I'm shifted to the left 3, and this means I'm shifted down 1. So this is kind of my little guide of what I'm expecting this graph to look like. So let's start with my domain. So remember, x plus 3 must be greater than or equal to 0. That gives me x is greater than or equal to negative 3. So this gives me from negative 3 to positive infinity for my domain. So my vertex should be at the point HK. I'm just going to check that by plugging in this -3. So I plug in -3, and I get -2 times the square root of -3 plus 3 is 0 minus 1. This gives me -1, which is k, so that does work. So -3, 1, 2, 3, -1. So there that is. My a is negative, so I'm expecting my range to be from -infinity to -1, but I want to wait and check a few more points to make sure that's the case. All right, again, picking nice points. So I want this to be equal to, I want x plus 3 to be equal to 1. So that means I should plug in -2, which will give me -2 times the square root of 1 minus 1. This will be -2 minus 1, which is -3. So I have -2, -1, 2, 3. Now I want x plus 3 to be equal to 4. That means I should plug in a value of 1 for x, which gives me -2 times 1 plus 3 is the square root of 4 minus 1. Square root of 4 is 2, so this is -2 times 2, which is -4, minus 1 is -5. So I have the point 1, -1, 2, 3, 4, 5. And my graph looks like that. So my range is from -infinity to -1 inclusive. Here we have a word problem. When an object is spinning in a circular path of radius 2 meters with velocity v in meters per second, the centripetal acceleration a in meters per second squared is directed towards the center of the circle. The velocity v and acceleration a of the object are modeled by the equation v is equal to the square root of 2a. This is a real equation from physics. Graph the function in the domain a is greater than or equal to 0. Now, there are a couple reasons this is the domain on which we are graphing this. The first is that it's the domain that has to happen here, right? So a needs to be greater than or equal to 0 for this to be satisfied. But it also just makes sense in the context of the problem. So looking at this, I want to graph this function. So my domain, I am going to check this. So my domain 2a needs to be greater than or equal to 0. That gives me a needs to be greater than or equal to 0. So my domain is 0 to positive infinity. So my vertex is going to be 0. And if I plug 0 in, v is equal to the square root of 2 times 0. This is also 0 for my vertex. And then I'm going to kind of plug in some nice values. So I have a and v. So I have 0, 0. This is my vertex. So I want this to be equal to nice numbers. So I think I'm going to go with, I'm going to plug in 2 because that will give me the square root of 4, which is 2. So I'm going to have the point 2, 2. And then let's go with getting this to be equal to 16. So if I plug in 8, I'll get the square root of 16, which is 4. So 1, 2, 3, 4, 5, 6, 7, 8, 4, and my graph looks like this. We want to make sure that we aren't drawing this like it's a straight line. This is a curve. Start your pen heading up and then curve it. So my pen starts up and then it curves to go through those points. What would be the centripetal acceleration of an object spinning along the circular path with the velocity of 4 meters per second? So v is equal to the square root of 2a. 4 is equal to the square root of 2a. I'm going to square both sides to undo this. So 16 is equal to 2a. A is equal to 8 meters per second squared. Make sure you include units in any word problem you do.